Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss how to represent a binary heap in Java. So friends, in our previous tutorial we actually discussed about the introduction to binary heap. So in this tutorial we will actually see how we can actually represent a binary heap in Java. So friends, in our previous tutorial we actually discussed that binary heaps are nothing but complete binary tree. And we also discussed that there are two types of binary heap. One is the min heap and other is the max heap. So friends, diagrammatically we represent a binary heap in the form of a binary tree, that there is one parent who has two children, and similarly the other levels have their own children. But when it comes to storing these elements, binary heaps usually are implemented using the array. So here you can see a max heap in which each node value is greater than or equal to the value of its children. So 9 is greater than 3 and 6, 3 is greater than 2 and 1, 6 is greater than 5 and 4. So in order to represent the binary heap, we basically implement it through the arrays. Also here you can see the max heap is having 7 elements as 1, 2, 3, 4, 5, 6, 7. So we usually store these elements into an array. So in order to store these 7 elements into this array, we usually create an array of 7 plus 1 elements, because the first entry of array we always take it as empty. So here you can see that we never store any element at the 0th index, and here you can see that we start storing these elements from index 1. So usually we keep the first entry of this array as empty. Also friends, we store these elements into an array by traversing this binary tree level by level from left to right. So here you can see at level 1, if we are traversing from left to right, we have only encountered one node, which is 9. So we store 9 into an array at the first index. Moving ahead, then we go to level 2, and at level 2 from left to right we first encounter 3. So we store 3 at index 2, and similarly then we encounter 6. So we store it at index 3, and similarly if we go to level 3, from left to right first we encounter 2. So 2 we store at index 4, and similarly the other elements. Also friends, in the last tutorial we discussed that binary heaps are complete binary tree, that all the levels are filled, and if all levels are not filled, then only the last level is the level which is not filled, and the elements are arranged in such a way that the left side is not empty. So here you can see why we are taking it as complete binary tree. So let's suppose if 2 is not present. So when we store these elements from left to right in an array, so you can see that here in an array we will get an empty hole which will store a null value. So whenever we are representing a binary heap using an array, we don't want that any value inside this binary heap to be an empty or null. So therefore the binary heap are nothing but complete binary tree, where each level is filled completely, and if all the levels are not complete, then it is the only last level which is not complete, and all the nodes are as left as possible. So friends, binary heap has these two properties. One is that it should be a complete binary tree, and second, it should follow the heap order property. So the heap order property is what we discussed, that each node should have values greater than or less than the values of its children. And if the values are greater than its children, then it's a max heap, and if the values is less than its children, then it's a min heap, which we already discussed in our previous tutorial. Also friend, if we represent these indexes here, then it would look something like this. That we have filled this array from left to right, level by level. Moving ahead. Also friends, in our previous slide we discussed that how we can represent a binary heap in the form of an array. So here you can see this max heap is represented in the form of an array. So whenever you perform any calculation over this array, we are basically provided a particular index and we need to calculate basically its parent or its child using some formula. So here you can see if we are at node having value as 9. So in the array it is at first index, and if we look for its children, then it has two children. One is having value as 3 and other is having value 6, and they are at index 2 and 3. So one has one children at index 2 and one has other children at index 3. Similarly, if we take a node having value as 3, then here we can see that it is at index 2, and if we look for its children, then they are at index 4 and 5, which means that index 4, which has value 2, and index 5, which has value 1, are children of index 2 whose value is 3. So here you can see 3 is parent to 2 and 1, in which 3 is at index 2, 2 is index 4 and 1 is at index 5. So here value at index 2 is parent to value at index 4 and also value at index 5. Similarly, if we take the node having value as 6, then here you can see 5 and 4 are children to 6. If we take this representation into an array, then 5 is one children of 6 and 4 is the other children. So friends, here you can see that how this binary heap is represented into this array and how we can represent this parent-child relationship into this array. But in order to calculate this parent and child of a particular index, there is a formula. So we already saw that children of first index is 2 and 3. We saw that children of second index, which is this node, is 4 and 5. And we also saw that children of third index, which is this, has children at 6 and 7. So if we are given any particular index, let's say kth index, and we want to find its children, then the children of kth index would be 2 times k and 2 times k plus 1. So here children of 1 is 2 into 1 and 2 into 1 plus 1. Children of second index is 2 into 2, which is 4, and 2 into 2 plus 1, which is 5. Children of third index is 3 into 2, which is 6, and 3 into 2 plus 1, which is 7. So friend, this is the formula which we use in order to find the children of any particular index. We simply substitute that particular index value here and we get the values of its children. So friend, this was the formula to calculate the children of any particular index. Now let's say if we are given any particular index and we want to find its parent index, then here you can see the parent of 7th index is 3. So here the parent to the 7th index is 3. Parent of 6th index is 3. So parent of 6th index is also 3. Parent of 5th index is 2. So this is the 5th index and its parent is at 2. So friends, in order to find the parent of kth index, the formula would be simply k by 2. So here you can see that if we are at 7th index and we want to go to its parent, then what we simply do is we do 7 by 2, which gives us a value of 3.5. And as we are dealing with the integer values, this integer value is rounded off to 3. So 7 by 2 gives 3.5, and if we take the integer value of it round off to 3. Similarly, the parent of 6th index is 3, which is evaluated as 6 by 2, which is 3. And parent of 5th index is 2, is being evaluated as 5 by 2, which gives us a value of 2.5, and if we round it off we get 2. So friends, in this slide we discussed that whenever we represent a binary heap in the form of an array, and if we are at any particular index, then we can traverse to its parent or to its child using these formulas. If we want to traverse to its child, we simply multiply it by 2, which will traverse it to the left child, and if we add a 1 to it, we simply go to its right child. And similarly, if we are at any particular index and if we want to go to its parent, we simply divide that index by 2 and we will reach to its parent index. So friends, in this tutorial we actually discussed about the representation of a binary heap, and we also discussed that we are actually representing a binary heap in the form of an array, where this first element of the array is left as empty and we start our insertion of these elements from the index 1. And we also discussed that how we can actually calculate the children of any particular index and also the parent of any particular index. I hope you liked this video. Thanks, have a nice day.